two identical glass with refractive index mu g is equal to 3 by 2 equiconvex lenses of focal length f each are kept in contact. The space between the two lenses is filled with water with refractive index 4 by 3. What is the focal length of the combination? To solve this problem, we need to find the focal length of the combination of two identical equiconvex lenses each of focal length f, which are placed in contact with each other, and the space between them is filled with water of refractive index mu w is equal to 4 by 3. The focal length of a single equiconvex lens, that is a glass lens, is given by the lens maker's formula 1 by f is equal to mu g minus 1 into 2 by R. For the glass lens, substituting mu g is equal to 3 by 2, we get 1 by f is equal to 3 by 2 minus 1 into 2 by r, which is equal to 1 by 2 into 2 by r. Thus, the radius of curvature r is equal to f. Next, the space between the two lenses is filled with water, which acts like a concave lens in this setup. The focal length of the water, which is concave lens, it is given by the formula 1 by f dash is equal to mu of water minus 1 into minus 2 by r. Now, substituting refractive index of water, which is given 4 by 3, and r is equal to f, we get 1 by f dash is equal to 4 by 3 minus 1 into minus 2 by r is nothing but f, which equals minus 2 by 3f. The power of the combination is the sum of the powers of individual lenses. The power p of a lens is given by p is equal to 1 by f. So, the total power of combination can be given by p is equal to 1 by f of all the combinations, which is equal to 1 by f plus 1 by f dash plus 1 by f. Substituting the value of f dash, we get 1 by f plus minus of 2 by 3f plus 1 by f. Taking LCM and simplifying, we get 2 by f minus 2 by 3f, which equals 6 by 3f minus 2 by 3f, which equals 4 by 3f. Thus, the total focal length is f of the combination is equal to 3f by 4. So, the correct answer is option B, 3f by 4.